So we're still in section 2.5, and we're starting with example 3, which will be on page 2 of your handout, and we're dealing with the properties of the logarithms. So we want to rewrite this in exponential form. So 8 raised to what power gives me the 4th root of 1/2. So I need to get both with the same base. So this would be 1/2 to the 4th. I can then make that a negative exponent. To make the same base. So I'm now going to drop the base of 2 to solve my resulting piece. Multiply by the reciprocal of 3, which is 1/3. Gives me x equals a negative 112 as my answer. Example 4 and 5 are using the shortcut rules at the end of the properties that were listed on the first page. Natural log has this is a base e, so these have the same bases. So since they're inverse of each other, you can think of it as canceling. So again, the reason why is this would be e to what power gives me e to the 3rd. So it's x equals 3. Number 5 is e to what power gives me 1, which is x equals 0. So I showed you without using the shortcut rules, but it is okay to use the shortcut rules that were listed with D and F. Now we're going to write expressions as a sum, difference, or product of logs. We want to have absolutely no products, quotients, or powers left in our argument. So this first one we are going to break up into a sum. It's pretty straightforward. On number 2, we're going to break it up using a sum and then also a product, but you need to be very careful of your signs. I do take 2 steps to do this problem. On the very beginning piece, so I use the division rule, and now I'm going to use my product inside to rewrite those and break them up. This is where you got to be careful. That minus sign, even though it's an addition for here, when I break it up, there is a minus sign that has to go throughout, so that would be a log base 7 of y. Last piece we need to do is that this can be simplified, so everything else comes down. Using my shortcut rules, that log, sorry, there should have been a 7 there. My log base 7 of 7 is 1. Looking at number 3, we are going to again use our difference first, and then we're going to break up using our power rules, product rules. We're pretty much going to use everything in this problem. So natural log minus the natural log. I have a product here still, so I'm going to break that up. I'm going to go ahead and do one quick step there. That 5 cube root is the same thing as 5 to the 1/3 power, so I'll be able to use the power rule next. And here, same thing. This would be to the 1/4 power. So my last step on this problem is to bring down those powers. And that is my answer. You want no powers left. You want no products, no quotients, and nothing that you can simplify directly. Going to our next group of examples, these problems are having you do the same thing we did above, but you want to simplify in the end and only have letters and coefficients and numbers there. So we're going to first use our properties to break it up, so that we can use the 2 and the 3 logarithms above. So I can rewrite Log base b, 19 is 9 times 2. So now we can break that product up. So this one here on the right-hand side is doable to go ahead and plug in for. This one here, we can rewrite 9 is 3 squared, so the 2 can come down in front using the power rule. So now I can substitute in using the rules from above. So log base b of 3 is c, log base b of 2 is a. That is my answer. So at this point right now, again, we're just practicing using the properties that we need for these problems. So next we're going to deal with the change of base formula. So again, remember we can change it to any base we want as long as we're using the same base top and bottom. And specifically, we're going to use the natural log most of the time because in this class, that's what you're going to be asked to use. So we're going to rewrite this problem, natural log. The 210 is above the 12, so that's how I remember to put the 12 on the bottom. And then we use our calculator. And when you type it in your calculator, look and see what it asks us to round to. It asks us to round to the nearest thousandths, which is 3 decimal places. Again, this should be review from college algebra. So number 2, natural log of 0.12 over natural log of 2.8. Do be careful when you're typing it in your calculator to make sure you close parentheses. And what I mean by that is that's here. A lot of your calculators open it, so you need to close that parentheses before you divide. For this problem, you should get a negative 2.059. Our next grouping is going to be equations that we need to solve. But notice in these directions, they ask for you to round decimal answers to 4 decimals. So we're going to still convert in terms of using exponential relationship with logarithms. We're going to see if we can get the same base on both sides. And if we can't, we may have to do something else. These problems, because they're starting with a logarithm in the problem, you have to check your answer for the domain. So what I mean by that is use those rules from above. Base A, which is here, has to be positive. Okay. So we're going to first rewrite it, remembering again that a logarithm is solving for the exponent. Now we need to get rid of that negative 2 exponent on the left, so I am actually going to raise both sides to the negative 1/2 power, because the negative 2 times the negative 1/2 will give me x to the first power. Negative exponent means put it in the denominator. So now we have 36 to the 1/2 power in the denominator, which can be simplified. X equals 1/6. Make sure we didn't break any rules. That's okay. Number 2, start off again using the definition of a logarithm. 8z equals 16. We're going to get the same base on both sides if it's possible. That's always your first instinct. Drop the bases. Solve for the exponent. How I could check number 2 in my calculator quickly is I could use a change of base formula using the natural log of 16 divided by natural log of 8 and make sure I get the same answer. Going to number 3, again I'm going to use the rule, the definition. 4 squared equals 5x plus 1. Simplify and solve for my variable. So I'm going to subtract 1 from both sides. Divide by 5. Double check because the domain rule on this problem says this whole piece has to be positive. When I plug in 3, I get 15 plus 1, which is 16. That works. 2 more problems to finish page 2. Now we're going to use the logarithm rules to put it back together, because to use my definition of a logarithm, I need a single logarithm on one side. So first step, rewrite it as a single logarithm. Once it's a single logarithm, I can use the definition to rewrite. I now have a proportion, which means I can cross multiply to solve. So I get x plus 3 times 1 equals 4x. Subtract the x from both sides and divide. Make sure it does not break either one of your domain rules. And in this case, those two pieces I highlighted in yellow have to be positive when I plug the 1 in. It works on both of those locations. Finally, number 5, we're going to combine the logarithm. Use the definition. Simplify by foiling out the right-hand side. Subtract 9 from both sides. Now, since it's a quadratic set equal to 0, I can use the zero product property. So this will be an x plus 7 and an x minus 3. Double check your signs to make sure you're correct. This gives me x equals negative 7 using the zero product property. This one gives me x equals 3. Check again from the original problem, if I were to plug it into both of these spots, that they would be greater than 0. We can see right off the bat, if I plug in negative 7 in the first piece, it's going to be negative, so that doesn't work. If I plug in 3, I get a 1 here, that's okay. I plug in 3 here, that's okay. So x equals 3 is my answer.